we have never been able in any way theoretically to examine the central Darwinian claim that natural selection and random variation can account for a great deal of complexity. If you look at the history of physics, for example, what did Newton do in the 17th century? He said, well, the planets are being attracted to the sun by a force. It's not any kind of force, it's a inverse square force. And then he went and showed that if you make that assumption, the result will be an orbit that conforms exactly to the observed orbit, say, of the Earth or of Mars. It will be a conic section. And then he proved the converse, that if it's a conic section, the planets must be attracted to a central source by an inverse square law. There is nothing like that in biology, in Darwinian theory. A kind of a canonical demonstration that this mechanism, random variation, natural selection, is adequate to the generation of this level of complexity. From the point of view of the serious sciences, without that kind of a demonstration, one is completely adrift. You have no idea whether the mechanism is adequate for its intended purposes. This is the second point. Third evidential piece of the puzzle. Look, you turn to the serious sciences, you turn to general relativity or quantum mechanics. I can program a computer with the equations of general relativity or with the equations of quantum mechanics, and I can say, all right, what are the consequences? I can actually see the consequences emerge in a simulation. We can't do any of this in biology, and that should prompt any reasonable person to ask, why not? If this is such a simple mechanism, which can easily be programmed on a computer, how come we can't set up a computer and create something of biological-like complexity? How come we cannot see the unfolding of an evolutionary process the way we can see the unfolding of an evolutionary process in physics? It's a very serious question. I've looked at all the genetic algorithms. I'm trying to write a genetic algorithm myself. And the sheer fact is, without a tremendous amount of very special manipulation and ad hoc constraints, the computer is not going to generate anything realistic if it uses Darwinian mechanisms, and it will generate something realistic only if it doesn't use Darwinian mechanisms. This is an important point. 50 years after the computer revolution began, we have a splendid tool for assessing the intelligibility and viability of Darwinian theory, and everything that we know, and I think this is the uniform experience of anyone working in genetic algorithms, indicates these mechanisms will not work. They will not work for their intended purposes. And finally, there's the utter absence of laboratory evidence. I mean, random variation, natural selection, we should be able to start manipulating organisms. When we look at dogs, no matter how far back we go, it's dogs. When we look at bacteria, no matter what we do, they stay bugs. They don't change in their fundamental nature. There seems to be some sort of an inherent species limitation, and we have no good explanation for this in terms of Darwinian theory. We should have far more flexibility, far more plasticity under laboratory conditions than we actually do if Darwinian theory or anything like that were correct. What we see in nature, what we see in the laboratory, is very highly bounded variation, cyclic variation, as for example finch beaks in the Galapagos Island. That's about all we see. Small variations. Why is that if Darwinian theory is correct? These are evidentiary points that I think need to be stressed, need to be examined openly, honestly. And they never are, of course. Never are. Look, the stuff about finch beaks is certainly interesting. Let's not confuse ourselves about that. The question is, can it be extrapolated, or does it represent cyclic variation? I can say, here's an account of how the eagle flies. Look, I get up, I jump in the air, I flap my hands a couple of times, and I land a few feet from where I started. Thus the origin of flight. The obvious response is, this is nutty. You can flap your hands as long as you want. You won't fly like an eagle. The argument from extrapolation can work in some circumstances. It fails in other circumstances. Plainly, in the case of a human being who jumps 2 feet in the air and then lands 2 feet from where he started, the argument from extrapolation fails. What persuades you in the case of the Galapagos finch that what seem to be cyclic variations are the start, the commencement of a grand process of speciation? That's a step in the argument that has to be completed. It's not enough to say, well, it's more of the same. It's not more of the same self-evidently. It can easily be bounded variation of exactly the same sort as we see in any species experiment. Now, The contrary may be true. We may be seeing the development of entirely new species. The Galapagos finch starts off as a finch, and within 100 million years there'll be a Galapagos elephant. Could be. But we need a whole lot more by way of evidence than a couple of nutty journalists going down there looking at finch beaks and writing a Pulitzer Prize-winning book. A whole lot more of this is to be serious science. I mean, this doesn't even pass the threshold of anecdote. Finch beaks change in size. Yeah, they do. They change in shape too. It seems to be correlated with seasons. There seems to be a regress back toward the mean when the seasons change again. If this is the part of a spectacular evolutionary extrapolation, let's have additional reasons for thinking that. Otherwise, we're not even talking about a scientific hypothesis. But the idea that mutations are the driving force encounters a fatal difficulties. Almost all mutations are deleterious. Almost all of them do the organism absolutely no good. In fact, we have a devilishly hard time finding any mutations that do the organism any good whatsoever. That's one problem. The second problem is that by now we should be attentive enough to look for contrived circumstances in which we can test this idea that mutations, by definition random, work is the engine of evolution. What we have are a variety of lifelike systems, books, for example, or computer codes. And what we know is that unless we do a lot of careful stage management, arbitrary events in either books or computer codes tend to screw the code of the book up irreparably. Now there's a large question here. If I take a copy of Windows 2000 XP and I start introducing random changes, within a very short while the code will crash. The whole system will be useless. Why exactly is this not happening in living systems?